The forklift transports raw materials for the Nokia 3310 through the warehouse corridor. As it approaches the conveyor belt, materials are prepared for processing. The forklift transports raw material pallets for the Nokia 3310 through the industrial corridor. It approaches the conveyor belt entrance for the next stage of processing. The forklift places the pallets of components beside the conveyor intake. The conveyor motors start, and the belt begins moving components forward in sufficient intake for production. The components for the Nokia 3310 begin their automated journey on the conveyor belt. A robotic arm precisely sorts chips and connectors into their designated trays. This efficient process ensures reliable assembly for the durable phone. The arm places the assembled tray onto the rolling cart. It then retrieves a processor component for sorting. The component is deposited into the labeled bin. The cycle repeats with high precision. Initiating inspection of Nokia 3310 components. Calipers confirm dimensional accuracy. Scanner verifies serial data. Tray advancing to assembly. The metal frames for the Nokia 3310 enter the automated cleaning tunnel. Steam rises as the conveyor moves them forward. The machine door slowly closes to seal the process. The metal parts enter the wash cycle, where high-pressure water jets remove any residue. Next, industrial air jets blast away moisture. Finally, exit rollers push the clean parts outward, ready for assembly. Dried components of the Nokia 3310 emerge on the conveyor for inspection. The belt curves steadily toward the next production hall. Components enter the main factory hall marked Nokia 3310. The conveyor disappears into the next manufacturing zone. The Nokia 3310 component crates exit Phase 1 on the conveyor belt. The conveyor merges with the main automated transport line in the logistics corridor. AGVs transport sealed Nokia 3310 component crates across the factory floor. The AGV slows as it approaches the scanning station for verification. Scanners activating. Laser sweep commencing. Scan confirmed. Data logged. Gate opening. Crate cleared. Scanning logistics labels for the Nokia 3310 at the checkpoint. Labels verified. Access granted. The gate is now opening. Pallets move steadily onto the heavy-duty roller conveyor, heading toward the internal transport elevators. The system feeds directly into the freight elevators, ensuring seamless vertical transport. The elevator doors open onto the core manufacturing logistics level. The conveyor belt activates immediately ahead. Robotic arms and AGVs manage the flow of materials. Forklifts transfer pallets of the iconic Nokia 3310 from conveyors to the staging zone. The forklift turns and places the pallet onto the marked floor position.
Adjusting the pallet for alignment. Signaling readiness with a thumbs up. Pulling the lever to activate the conveyor.
Nokia 3310 components enter the main production intake corridor, labeled Material Entry phase, carrying the pallets towards the factory exterior doors. Corridor lighting transitions, revealing the next phase of assembly. Pallets of Nokia 3310 components move through automated doors into the exterior loading zone. Guided vehicles navigate to the trucks, where workers prepare for efficient loading. At the Nokia 3310 factory, supplier trucks from Qualcomm and Foxconn are docked and idling. This efficient Hynix components from the Wingping Trullebeller. Dock workers open the container doors, revealing pallets of Nokia 3310 materials. A forklift moves in, its forks sliding under the pallet. The conveyors pull the Nokia 3310 pallets into the factory through the insulated doors. The doors close securely behind the pallets, completing the automated entry. The intake corridor, where conveyor systems guide essential materials for the Nokia 3310 deeper into the facility. This automation, the main conveyor splits towards the efficient handling for all components. No damage, seal is intact. Confirmed, stamp it. Approved. Pushing forward. Crate entering weighing gate, weight registered. Proceeding to dimension scan, green status confirmed. Next crate queued, system efficiency maintained. Pallets are redirected onto overhead conveyors, ascending toward the preparation floor. This automated system ensures seamless transport as goods move continuously through the facility. Nokia 3310 materials arrive at the initial processing entry zone, Phase 4. The conveyor feeds these materials directly into the preparation machines. The Nokia 3310 component crates exit Phase 1 on the conveyor belt. The conveyor merges with the main automated transport line in the logistics corridor. Sensors identify each component's type and size. Mechanical gates separate the components into dedicated lanes. Components are directed into bins, which slide forward as they fill. Components are carefully placed into labeled trays. The filled tray is placed on the conveyor belt. This ensures efficient processing. Anti-static conveyors transport trays of Nokia 3310 phones toward cleaning stations. The trays align precisely under the nozzles for targeted cleaning. Precision air jets dislodge dust from the components. Vacuum suction captures and removes particles. Clean trays advance, ensuring pristine assembly. Components proceed through the drying tunnel, where humidity is precisely controlled. At the exit, the rollers engage, smoothly transferring the parts. This automated process ensures uniform preparation for the next stage. Under intense, magnified lights, workers inspect the parts. Once approved, the parts are slid forward. This process ensures the highest quality standards. The laser head etches the internal batch code with micron precision. Cooling fans maintain thermal stability during the process. The marked component exits onto the conveyor belt. Nokia 3310 components are precisely sorted by the robotic system. The parts are automatically grouped into assembly-ready kits. The kits are then pushed onto the main assembly conveyor. The Nokia 3310 component kits enter the core manufacturing line at phase 5. The conveyor locks into the assembly line, securing the components. Robotic arms begin the precise assembly process. Nokia 3310 component kits arrive at the core line. SMT machines power on, ready for assembly. Conveyors feed PCB panels into the SMT loader. Automated precision ensures efficient production. Robotic heads activate, their nozzles picking microchips from feeders. The heads place the chips precisely onto the moving Nokia 3310 boards. The conveyor advances the panel as the automated process continues. The inspection lenses activate, scanning the solder paste in real time. Approved boards roll onward as the next enters the inspection zone. This automated precision ensures flawless production. The Nokia 3310 circuit boards enter the reflow oven, where controlled heat melts the solder. The conveyor belt carries them through the glowing tunnel. The boards emerge with components permanently soldered in place. Cooling conveyors stabilize the freshly soldered Nokia 3310 PCBs, aligning them for the manual inspection station. Gloved hands precisely insert connectors onto the Nokia 3310 PCB. Each component is placed with steady, practice motions. The completed board returns to the conveyor for the next phase. Rejected units are diverted into the rework lane. The main line continues forward without interruption. This automated process ensures quality and efficiency. The reinforced PCBs are stacked with precision in these controlled racks for the next assembly stage. A forklift approaches, ready to transport the completed racks to the next station. The forklift transports the completed Nokia 3310 core electronics through the assembly hall. It moves steadily toward the assembly integration zone, where the next phase of production begins. The bare PCBs arrive at final assembly, where a worker's hand begins the integration process. The hand reaches for a PCB, preparing to mate it with the plastic body shell. Align the PCB and lower it into the housing. Press down until it clicks into place. The jig slides forward for the next insertion. Repeat the process for the next unit. The rubber keypad membranes are precisely aligned over the contact pads. They are lowered and pressed firmly into place, creating a secure connection. The assembly advances as the phone body moves forward on the conveyor. The vacuum gripper precisely places the LCD screen. Adhesive alignment tools hold it steady. The tool releases, and the screen-assembled unit moves ahead. The alignment tool is peeled away. Insert the speaker module into the upper cavity. Use the tool to secure it in place. Now place the microphone module into the lower cavity. Place the completed unit onto the conveyor. Inserting the speaker module into the top cavity. Next, securing the microphone module in the lower slot. The unit is complete and placed on the conveyor. Inspecting battery contacts on the Nokia 3310 units. Tool makes contact, testing for continuity. Contacts verified. Now preparing the battery slot. Unit placed into holder. Slot is aligned. The battery is inserted into the phone body. It is then secured with a mechanical press. The powered unit advances down the line. Robotic arms precisely group the disassembled components into assembly-ready kits. The completed kits are pushed onto the main assembly conveyor. The automated process ensures efficient and error-free production. The fully assembled Nokia 3310 phones move steadily along the conveyor. They enter the automated system zone, where precise robotic machinery takes over, ensures efficient, high-volume production. The assembled Nokia 3310 phones proceed along the conveyor for automated inspection. A robotic arm lowers to scan each unit, ensuring quality and functionality. This precise system maintains the legendary durability of the 3310. Here, assembled Nokia 3310 phones enter the inspection line. The robotic arm lowers precisely to begin the quality check. The robotic arms rotate the devices for precise optical alignment. The phones are placed forward for inspection. Final adjustments ensure perfect positioning. Alignment complete. The devices are ready. Probes are now testing the charging contacts. The phone rotates to expose the internal circuitry. Probes contact the circuit board for continuity checks. Probes retract. Test complete. The Nokia 3310 units proceed through vibration resistance testing. The platform vibrates at controlled frequencies, testing structural integrity. Mechanical arms now grip and release each unit. The phones continue, passing the durability test. Initiating screen clarity and pixel response verification on the Nokia. The robotic cameras align precisely with each screen to capture pixel shifts. Screen-tested units slide ahead on the conveyor for sequential analysis. The automated laser head applies the barcode to the internal frame. This precision process ensures each unit meets strict quality standards. The engraved unit exits the station for final assembly. The automated laser engraving process begins. A barcode is etched onto the Nokia 3310 internal frame. The unit exits the station. Automated systems are scanning the phones. Real-time data logging captures each serial number. The conveyor leads to the finishing zone. The Nokia 3310 phones exit the automation hall, advancing along the conveyor toward the precision finishing area. The system now enters the calibration section, ensuring each unit's exact specifications. The Nokia 3310 units enter the precision finishing line on soft belt conveyors. The conveyor guides the phones into the polishing station for a flawless finish. This ensures the highest quality in every unit. Automated microfiber heads polish the durable shells of the Nokia 3310. This precise process ensures a smooth, high-quality finish. The polished phone shells advance to the next stage. Precision airbursts clear the speaker grille. Next, the keypad gaps are targeted. The cleaned unit slides onward for assembly. Initiating precision calibration of the Nokia 3310 keypad. Testing button responsiveness sequentially. Calibration complete. Releasing the device. Initiating automated tuning sequence on the Nokia 3310. Relays engaging. Coils adjusting signal parameters. Tuning complete. Signal optimized. Phone moving ahead. The calibration sequence begins. Observe the grayscale bars on the display. Adjusting brightness. Increase the value to optimize white levels. Now, set contrast for deep blacks and clear details. Light booth opens to full view. Initiating display brightness and contrast calibration. Sensors are measuring light output and uniformity. Adjusting for optimal levels. Calibration complete. Light booth is opening. Workers perform the final tactile inspection, rotating the Nokia 3310 carefully. The phone is then placed onto the next belt, continuing its journey. Calibrated Nokia 3310 phones enter the final verification conveyor. The conveyor leads toward the testing labs for quality assurance. Nokia 3310 units exit the finishing zone, entering quality control. Automated doors open to the inspection area. Under intense lights, each unit undergoes rigorous testing. The Nokia 3310 units enter the quality control laboratory on the conveyor belt. The conveyor aligns each phone precisely under the automated testing rigs. Here, sensors perform comprehensive quality checks. Initiating automated power-on sequence for the test grid. Screens are illuminating simultaneously. Test arms retracting. Sequence complete. Initiating voice and microphone clarity test for Nokia 3310. Robotic arms moving phones forward to testing heads. Signal transmission active, monitoring audio quality. The machine begins its endurance test, rapidly and repeatedly pressing the buttons on the Nokia 3310. This demonstrates the keypad's durability under extreme, continuous use. The machine now releases the unit. The vibration table shakes the Nokia 3310 units, simulating transport stress. After sustained shaking, the table slows to a stop. Initiating drop sequence, monitoring structural integrity. Impact registered, retrieving for analysis. Unit intact, test complete. This is the RF shielded chamber for signal strength testing. Inside, the Nokia 3310 is isolated for controlled analysis. Opening the chamber door reveals the device under test. This is an RF signal strength testing chamber, fully isolated for precise measurements. The chamber walls are lined with RF absorbent material to prevent signal leakage. The chamber door opens, allowing access to the test enclosure. Inspectors review pass-fail data for each Nokia 3310. One inspector signals to advance the line. The process continues seamlessly. The fully approved Nokia 3310 units exit quality control. Their legendary reliability is confirmed, moving toward packaging. The conveyor enters the packaging zone, ensuring efficient processing.